Okay, so here is what we've learned so far. We've learned that when we look at equations, we can have two branches. We can have either this side or this side. So we've learned when we look at something and we determine, hey, there's only one variable type in that equation. So this would be an example. We can just isolate it, and that's just your algebra skills. Okay, then we noticed if we ever had two variables, so an x squared and an x, that's two variables. Okay, whatever we do, boom, we need to make our equation equal 0. That's our very, very, very first instinct. Okay, once you have it equal to 0, you would go through your list. Can I factor it? So we've now learned that there's 4 factoring styles. So your factoring styles are GCF, simple trinomial, and we learned the complex trinomial on Friday, and the difference of squares. Okay, the next thing we're going to have to learn is what if it doesn't factor? We're going to learn that there's a formula. Okay, let's look at a mix-up of equations. So I gave you some equations. So on your test, I'm going to have some sections that say solve by factoring, and it'll just be simple trinomial, solve by complex trinomial factoring. Then I'm going to have a section on your test that's just solve, and you got to figure out what to do, and it could be anything. Okay, so I have my algebra branch thought process here. So do I see one variable style or two? Two. What's your very first thing when you see two variables? You have to have an equation that equals 0. So in other words, we're going to have to rearrange. I'm going to do that way. Okay, so I rearranged because I do have to have an equation equal to 0 if I have two variables. Now I go through on my algebra sheet. What does this look like? If I was to factor it, which style would I be recognizing? Simple. So x and x are in two brackets. And then we do what is simple rules. Multiplies to the end, adds to the middle. So 4 times 5 is 9, or is 20. Minus minus. Right? Because it has to multiply to positive, so they're both the same. So x equals 4, x equals 5. Okay. Number 2. What is the thing I don't like when I'm looking at this? I don't like that there's a negative in the front. Okay? What are some things we can do if there's a negative in the front? There's three things that you could do to tackle this problem. Anybody have a suggestion of how we could not have that negative in there? We could GCF it out. Okay, so that's one style. What's another math strategy I could do to get rid of that negative one? You could, in algebra, you could just multiply each side by -1, right? Does that work with algebra? If you multiply this side by -1, you do the same thing to the other side. So that would have been another strategy. Or I could move everything to the other side of the equation. Okay, so those are 3 things that you could have thought of to do to get rid of that negative. Doesn't matter what you pick, you're going to end up with the same. So let's pick the GCF method. X squared is now positive, right? Everything's going to change. So plus 4x changes, and a minus 21. So if you had times both sides by -1, you would have just got that. If you had moved to the other side, you would have got this, but flipped around. Okay, let's factor. And I'm recognizing something. I'm saying, hey, that's a simple trinomial. I recognize it. So I need something to multiply to 21. 3 times 7. And I need a plus 4.
Negative.
Okay? And again, that -1 isn't involved in our solving process. It's not changing our numbers. It's just changing that I have a parabola heading downward. But it's not changing the fact where I'm crossing. Okay? It's not changing the numbers where I'm crossing. It's just changing my direction of my parabola. That's all that was doing. Okay, number 3. What is the awkward thing I don't like in this? I don't like this fraction. Okay, so I'm trying to think, like, how could I make that look better? What could I do to get rid of that fraction in math? How do you get rid of a fraction 5/2? Well, changing it to a decimal would be 2.5, which doesn't really help me again. How do I get rid of this problem where I don't like it has a divide by 2? How do you get rid of that problem? Multiply by 2. So I'm going to, in algebra, if you do something that you're creating, you have to do it to everything. Okay, just to make it balanced, you're doing it to everything. Okay, so 2x squared. Okay, what is that going to change to if I do 5/2 times 2? Now it's just 5. 5/2, here's what I did. 5/2 times 2, right? And that's what happened. Okay, and then plus 2. Okay, so did you notice I did that to every part of it, all 3 parts of it. And then 0 times 2 is still 0, so that's good. Okay, do we recognize this as something we're familiar with? Complex trinomial. Okay, I'm going to flip. That's how we're starting. So the first times the last makes a plus 4. 1, 4, or a 2, 2. Whatever I'm using needs to get me a plus 5 in the middle. So plus 1 and a plus 4 make multiply to plus 4, add to plus 5. Under the F, to get the F, I could use the 1x, 2x. And under the L, I can only do a 1 times the 2. What are you putting together in the O and the I positions? What are you partnering together? I need a 4 partner and a 1 partner. I need a 1x and a 4x. 1x partnership and it's 4x to be partnered. Okay, so lining them up in brackets. I do the first and the first. So we picked 1x times 2x. Okay, then I give myself an O swivel and an I swivel to make sure I'm lining up my FOIL positions properly. So I put the 1x with a 1 and a 2x with a 2. My big suggestion is FOIL it back out. Does it get to your original, right? You can FOIL it yourself. Okay, first bracket, x equals -2. And do you remember this one? It's a fraction answer. Opposite, divide. Always opposite and divide. Okay, this is always opposite and divide, but our divide is 1. So that's why we weren't writing it. Okay. Fourth question. What is wrong with it? I have one variable, I have two variables, okay. So what do I need to think about? 0, I need a 0. As soon as I see two variables, a 0. Which way do you want to move? Do you want to move this over to the right or do you want to move this stuff to the left? I'm picking that way. Why did I not want to do it the other way? If I move this over there, it would become -x squared. Now I've given myself another problem. I got a -x squared. Okay, be careful when you move. Every time you move something over, it changes. Okay, simple trinomial, so x and x, that's what I'm recognizing. And I need you to be careful here, the 2 times the 3 or the 1 times the 5. And you have to think about it because it all depends on your signs. Because the 2 and 3 both do 6, 5. 1 times 5 also do, oh wait, 1 times 6. 1 times 6 also multiply to 6 and add to 5. So which one?
1 and 6 with a -1. It's 2. It has to be 2 and 3 because they have to both be the same sign as if in both places.
They have to be the same sign. They have to both be either plus or minus, but in this case, they're obviously going to both be minus, right? So -2 times -3. Okay, do you see how that one, I end up getting a lot of people picking the wrong combo because it's so close to doing what you wanted to, but it didn't match up with the signs. Okay, the middle one here. So this one is ready to go. It has a 0. No negative leaders. I don't like negative leaders. So I'm going to start this as a binomial. Okay, what times what, first times first, makes that? X squared. X squared. So this is like a trinomial, but it's just with a higher degree. What times what makes 36? 6 and 6, but that won't get me a 5. What's another 36? 3 and 12 won't make 5. 4 times 9, yep, that. 4 times 9 is 36. I need to end up with a -5 out of that. Okay, we did one of these on Friday. Something factors, something doesn't.
There's a difference of squares.
This one is a difference of squares. So it will factor. So x plus 3, x minus 3. Remember how to factor a difference of squares. A difference of squares is a simple trinomial idea. Just your numbers need to make 0 in the middle. That's why there is no third part of the trinomial. And this does not factor, so I write it, but it will not factor. So again, here's the reasoning why it's not factoring. If I want the bracket to be 0, x squared would have to be negative 4. Is it possible in math to square something to be negative? No. Okay, I'm just going to write this. You'll learn that when something doesn't end up with a x equals this, you're going to write, there's no solution on that one. But it's not that there's no solution to the problem. There's just no solution in that factor. So negative 3 and positive 3. Okay. Couple things you could do to actually solve this next one. But if I was to focus on my algebra branch, what do you see on your algebra branch? What could you first see when you looked at your branch? There's only one variable. There's only one variable here. There's only just the x squared part. There's no x. So what is my strategy when I'm only looking at one variable in an equation? Isolate it. Get it by itself. So I am going to move the 9. Algebra says get something alone. So I would minus 9 from both sides. So minus 9. What BEDMAS algebra step would go next? You have to divide it by a negative 1. And then to get x alone, I would be doing a square root. And this is not the correct answer. I could have done 3 squared to get there, or I could have done a negative 3 squared to get there. Okay, that's an easy mistake on a test, or just forget. It's a half a point, so try to remember. Okay, next question. Okay, we have multiple variables. We actually have 3 different variables. We have an x cubed, x squared, and an x. So I have a 0. That's good. So now I'm going through my checklist. Do I see a factoring style that I know?
Well, GCF because it's x.
I see a GCF. GCF is actually the one I always look for first, just to see, do I have a GCF? If I do, that's always the first to be done. So I think I heard somebody say every term has an x in it. That's the common part. So what are you going to be putting in there? X times x squared minus 13x and a plus 42. Okay, I took the x out of all those terms, or I'm understanding this is multiplying to that. Okay, so that was that. Am I recognizing anything else?
It's a simple trinomial.
This part is a simple trinomial. So I'm starting to recognize, where do I see all my factoring types? I cannot just forget about that x. It's still there. Okay, so this simple trinomial is xx. What is multiplying to 42? Do we know those numbers? 6 times 7? Are you using your calculator or your mad minutes here? 6 times 7. And then if I do negative, negative, that works? Okay, on this question, there's actually 3 x answers.
X equals 0, X equals 6.
This x could be 0, this x would be 6, and that x would be 7. Okay? I think I gave you a sneak peek at your grade 12. You're going to graph that. 0 at 6 and a 7. That's what you're going to graph in grade 12. Okay, and this last question. What is the part I don't like about this question? I don't like the fraction. The fraction is containing a divide by 2 and a divide by 2. So mathematically, I'm strategizing. How could I get rid of that? I'm going to times everything to balance it out. I'm going to times everything by 2. So 2x squared. Do we remember what this is going to do? Cancel out. So the bottom is gone on that because it just canceled it out. And a minus 3. Now I go through the process. What do I recognize? I see a complex, so I can flow that. So if the first times the last makes a negative 6 number, I could do 1, 6 or 2, 3. Oh, this is an awkward one again. It has to make negative 5, but both sets could make a 5. So which set is it? Because what do you know? 1 is going to be positive and 1 is negative. So which one would I use? 1 and 6. I need a negative 5 out of the deal. Okay? See again how that one was tricky because they both could possibly have made a 5 somehow, but it's all about the signs at that point. Okay. First, last. There's not many options. There's just one option for each. So now it's just about understanding how it's connecting in your FOIL. What are you partnering with what in your FOIL system? So I need a 1 partnership and a 6 partnership. A 1 partnership and a 6 partnership. Okay, think about how you're lining up the foiling. The first times the first. Check 2x squared. That's already the part that's done. Outsides and the insides go together to make that. So we made 1 with a 1 and we made a 2x with a 3. Those were our partners. So I have a 1x and a 6x. I need a plus 1x and a minus 6x. So there's the O, the I, check. We got to negative 5x on that. And then the last times the last, yep, negative 3. So do you see how I'm checking my work? Did I place everything right? Because I foiled it back. So x equals 3, x equals -1/2. Okay, what if on the test I said, what does this graphically represent connecting to last unit? What are we doing here? What do you want to draw me? What are those on a graph of something? They're the x-intercepts. So that's what's on a graph. That's what this is. And the shape of this is an x squared, and it's a positive x squared. So that's the shape of it. And does anybody know what the y-intercept would just be as well? Have to look at the original here. What's the y-intercept on this one? -3/2, which is what kind of decimal for you? -1.5? Okay. So just some connections on your test. I do make you do some visual connections on what's going on, and those are x-intercepts. This is the whole unit is what we're doing. We're doing x-intercepts. We're trying to figure them out.